down here.
She wanted to slap me, she can do it.
Oh no, she must be upset. And we are live. Yeah. Hey everyone, just doing some admin over here and and getting the people joining, and then we're gonna be on just now and see some stuff. Let us see, let us see, let us see, let us see. Just getting ready. Low power networking. Okay, send the invite, and then we're gonna be able to do this. Come on. Okay, hey everyone. Sorry, my collar is a little uncomfortable. Hey everyone. Yeah, so thank you so much for coming today, and I think this is the thing we're going to be exploring today is how to extend our I do have a write-up of this. I don't have to say it from memory. So we have this low power, well, not low power. We have this Bluetooth low energy application that we've been implementing for the last few streams right now. And if you've checked it out, you'll find that we've done all of this work to ensure the application is fast, it's responsive, and it doesn't have any blockers or and such. And basically what we want to do now is we want to explore how to enable our application to work in low power mode, or rather to work with, let me see if my audio is good. Yeah, to work with low power mode. All right, did I explain that correctly? Basically, the thing that is happening right now is our Bluetooth radio is always on, and our Bluetooth radio is always broadcasting, and the issue with that becomes that even though we're using Bluetooth low energy, just keeping advertising, like just having the radio on all the time makes it really heavy on power. If this thing was running on a rechargeable battery or on a cell battery, you would run out of battery in hours, even though you wanted the thing to be in the edge in the field for months or maybe years. And the reason for that is because the radio is just always on. It's always advertising. It's waiting for someone to come in and give them some data. So to that effect, let us first of all try and explore how much power we're using or in what states we are in. And then once we explore in what states we are in, we can then go back and start seeing how do we adjust it so that we can we can be in a correct or a low power state for longer if needed. Okay, so let's just jump in straight into the code, and then where's my mouse? Do I need my mouse? Yeah, I do need my mouse. It likes dying during streams. Anyways, please. Wait. No. It's funny that during Bluetooth streams, my Bluetooth mouse dies. It's really insane. Yeah, audio is connected. Can I connect to the mouse, please? And then can I also connect to yeah, which one's that? Thing is connected. The keyboard is connected. The mouse is connected. Okay, cool. So we have this custom BLE service. The first thing we want to do is we want to do kconfig such. We want to enable power management. Config. This is still loading. So let's open the app, and then once we have the app, and then we will start with a change in here, and then let's add a section in our project configuration, power settings. I would want to enable config power management. This is config PM stats. Yeah, let's just confirm those are actual things. I mean, I could no. So config PM. So yeah, this option enables the board to implement extra power management policies whenever the kernel becomes idle. The kernel informs the power management subsystem of the number of ticks until the next kernel timer is due to expire, and then that's basically, you remember that formula that we built up the other day, where number of ticks until it expires and number of ticks until the next expected event, and then it will balance between those and whether to go into power savings or not. So let's enable that. We've enabled, and then I think it's PM stats. Yep. And then we will have power management stats. Sorry, my chat keeps doing weird things. And then from power management stats we can check. And I think, if I'm not wrong, I prepared a snippet for this in the code. Yeah, here. Okay, cool. So let's do that and see how many. Is it PM stats? PM stats. Okay, cool. So let's go implement that in our. Yay, we're working in main today. That's so cool. So the first thing we need to do is probably add we probably need to add the power management it's PM and PM device or something, I think. So K P, is it after K or after P? So include Zephyr, and then this is going to be pm.h, I think, and then hash include Zephyr. I think it's PM stats, PM, and then it should be in PM state, maybe .h. Do those cause anything? Sorry on all of these things, things. So yeah, so this is our complete main. So let's start reading these states and see. So how are we doing this? So custom, I made some notes here. Struct PM state info, and then PM state, put the PM state into that, and then we can log one that thing. Okay. So every 2 seconds we will check the PM state. let's remove this. This is dead. That's our. Every 2 seconds, we will check the PM states, and we will check how long we were in each, in either the active state or in the active state or in the suspend or idle state. Okay, so let's make an struct, and then this will be PM state info. Am I right? So let's go to the Zephyr API documentation and look at that. PM state info. Yeah. Where? Let's see. That's the issue. PM state. PM state.h. That is why we are getting a complaint down below, and I think this should control struct PM state info. So that should give us that. So look, this PM state contains state ID, and then PM device disabled, whether or not this state triggers device power management, minimum residency durations, worst case latency required to exit this state. So remember how the power management system works. Is it expects it will use these two latencies. How much time does it take to get into this, and how much time does it take to get out of this? Then depending on that, it will adjust both of them. So let's fill this. Let's fill this every 2 seconds. So let's fill it. Oh my god, there's something wrong with my editor, so that whenever I'm in insert mode, things are okay, but when I'm not in insert mode, things are not okay. So I want to dog one, and then we want to use the API. I think I documented it here. It's here. I wrote it out. You don't have to remember everything. PM state get info, and then PM state active. Okay. So PM state get info. Let's pass in the info that we want to fill, and then let's do PM state active. Let's see that. PM state get info. Is it PM state info get? Info get. Yeah. PM state info get. Where are you? PM state info get. No, there's no such function. I must have been looking at old code. Please tell me you are a function. PM state get. Are you a What does this function do? No, I don't want to that preamp state. PM state info get. Let's go look at that in the Zephyr code. PM state info. It should be everywhere. PM stats, PM config PM stats. Let's look at that. Let's find a project that uses that, and then we can go see whether that actually does. We can see how that is used. Config PM stats. And in our documentation, config PM stats, config PM stats. Config PM stats. Really? PM. Getting PM states in Zephyr. PM state info get. Yeah, we can look at that. Something in here is gonna tell us how long we're in. PM device get state. No, I don't want that. I want to just get the whole. I want to get the whole. This is eventually, ultimately, this is just to know how long the thing was. I want to get the whole CPU, not just our device, because yeah, this gets a device, but I want to get the whole CPU. I can find how PM state info is used in the Zephyr code base, probably. Did I do that? Oh. PM state info there should be a power sample that I could actually use. PM state first, PM state info, PM state. Let's just go with that. Let's look at the power management sample, please. Let's go back and look at the power management sample. Maybe that has information on samples. Subsystem, PM, latency. No, this is not good. This is not good. This is not good. Because what I wanted to do is I wanted to get okay, so Zephyr cannot give us Zephyr can't give us the information we want, but I don't know how to make it give us the information we want right now. The reason being, I do not know how to get the complete PM stats. Yes. I don't know how to get but this is going to be the device driver, not the... Can we just run it with PM stats and see what happens? I mean, because if that's how it looks, yeah. So you see, there's it looks like we can only get device power time. Anyways, this is one of those things. I'll open an issue and then I can define it later. This is for the next time, basically. But basically, what those stats would have shown us is how long are we spending in the idle time, how long are we spending in the active time, and those are the two things that you're going to change. But this does not change what we need to implement. This is just an observation. Basically, this only helps us to observe whether our changes are taking effect. You can observe whether our changes are taking effect in many other ways. You can use a multimeter, you can use an ammeter, and all of those things. So let's go back and just get on. There's a tab. Yeah, the power networking somewhere. Anyways, so let's go back to here and let's put a pin on getting the power stats, but let's now explore how we can actually use power settings. So whenever we are starting our service, let's remove this code for now. Whenever we are starting our service, we will start this guy, BLE init service, okay? And then in this service, we go to, this service is basically starts our BLE service. Let's look at it. What this does is it runs this function here, and this function enables Bluetooth, and then once it enables Bluetooth, it will then how do we say this? It will then start advertising. The thing that we want to focus on is this first parameter, this of BLE BTLE advertisement start. Let's go look at that function. BTLE, come on. ADV start. It's a function, it's there. Yeah, so this function, as its parameters, excuse me, as its parameters it takes, the first item it takes is advertising parameters. And advertising parameters will be, this will be in, the advertising parameters will be BTLE are the ADV params or something like that. Now let's look at my hint notes. Excuse me. Thank you. So it will be part of BTLE at ADV params. What does that compose of? For some reason, this is why is OBS connecting? Disconnecting. It's good. It's good. And then there's chat. Lani accountant. Thank you. Yeah, sure, man. Coding every day. So let's look at these parameters and then we will see how they affect. So right now we're using BTLE advertisement, BTLE confast, this one, which is can I go to it? No, it's because it's in Zephyr and then it's but regardless, right now we're using a preset which is confast. We'll look at it just now, but we did look at it a few times. We can look at it again. But what that advertisement parameter does is it sets a number of things for us. Number one, it sets the identity handle of the thing. It sets the identifier of the Bluetooth thing. Those are all the normal stuff and normal parameter settings for Bluetooth. And then it sets a couple of parameters that are going to be quite important for us to set up the power. Number one, it sets the skip count of how many signals, or rather how many things should I skip. Basically, if there is no activity in the network, can I skip X number of items or X number of actions, basically. And then the next option after that is we have a minimum interval and we have a maximum interval. This is how long between sending advertisement packets. Remember, the Bluetooth thing is just saying I'm here, I'm here, I'm here, I'm here, I'm here. And you want to set up the time so that it doesn't have to be saying that every time, with every clock cycle. You can now start setting up parameters so that you can set this thing. Imagine you have a service, a Bluetooth thing on top of a, let's say, cell tower somewhere, and it's there as a as a beacon or something of some, but for whatever reason, it's there and it's far, and whoever interacts with this Bluetooth application only interacts with it once every week. They drive by and they come monitor it and they need to collect the data from it, and they just, they're usually there between 10 and 10 in the morning and 11 in the morning, and then the rest of the time they're not there. So what you can't do is you can do something like between 10 in the morning and 11 in the morning, you can be advertising quite a bit so that it's easy to receive. And then when the other times are, you can advertise maybe once every 10 minutes or once every however many seconds, so that you're saving power. Remember, every little saving of activity, you're going to cut out activity that the CPU has to take. And in order to do this, we have to move from BTLE ADV con, let's look at it. BTLE ADV confast 1, LE ADV con, I think it's fast. I see the issue. Come on, find it. What's my network today? My network is so slow today. BTLE ADV con. BTLE ADV con fast. Yeah. For some reason, my thing is so slow today. I wonder if it's just the internet. And that probably means answers why. That probably answers why the thing has been. I'm gonna grab the Zephyr docs and run them locally in order to con fast one. Okay, cool. So this is a preset. Oh, I got fast two, but fast one is just here. This is a preset that's going to be setting our parameters, okay? The value is BTLE ADV param, and then it sets the LE ADV option connectable, and then it's gap, the interval for minimum, the interval for maximum, and then it sets a null at the end. So what we want to do is possibly build this packet by ourselves, and that's what I have an example of here. We want to build this packet of ourselves like this, and then once we do that, we can start using it basically. And I don't think I will use the secondary file. I'm just gonna use the connections, the options. Okay, cool. Need to read the blue. Okay, so let's build our own connection parameters. Let us build our own connection parameters based on the example that I had written, or rather the example that I got. BTLE ADV con params options. I think the option that the thing is using, I will stay at the same option. I have no problem staying with the same option. What I just want to do is change my minimum and my maximum intervals, so that we see whether it works. And I don't want to set my secondary file. Let's look at the Zephyr API documentation again. So this set ADV option connectable, that one. What's that one? Connectable advertising, yes, that's fine. And then fast int, that's an enum for, say, how long is that? It says interval to ms. Fast int. This is 100 milliseconds, 100 ms. And then fast int 2, which is 150 ms. So that's what we're setting. That's fast. Every 100 milliseconds we're running an advertisement. So that's quite insane. So let's see if we can. I think this is the peer ID. Yeah. No. A peer ID is also coming later. That's in bonding and security. But let's try and build this thing the way it is here. So struct BLE. Okay. So in the BLE service init, we don't want to do that in init. Let's build it out here. Is there possibly a thing, ADB param? Yeah, I can do this outside. So cool. How do I end up building it just by itself and naming it? I can't. Can I? Can I name something? Can I name something? But if I'm naming it, then just build it in here. Okay. Let's build it in here. Struct. First of all, where does it come from? Bluetooth H. No. come from? Bluetooth H. So let's see, are we doing that? Bluetooth H. Bluetooth H is gonna be the first one. Include. If you have any questions, you can stop me. Bluetooth H. Yeah. And then let's go here. That's imported the thing. So let's build our. Oh, my code is gonna become messy again. Build low power advertising params. I might even be able to see this one. Come on. What? BTLE ADV param LP ADV params, and then let's go with this, and then it's closed like that. It's gonna be a struct, so it needs to be closed, and then let's do that. And then the first thing we need to set is this doesn't, I think I'm gonna go straight to options because I don't want to set the other one. So options equals BTLE ADV optcon. Is that it? Yeah. Yeah. Optcon, and then I'll do optcon, and then double min and double max. I can do that. Can I just interval min equals, what did we set it? 1600, and then interval max that becomes 2000, and then secondary 5. No, what happens if I don't set it? If I just set those, and then what do I want to do? Just add it into the thing? Yeah, cool. So here I'll remove that. Let's remove you and do and LP ADV, and then I would like to put this in one line, and then can I build this? Will this really? Come on. West control R NRF 552. Cool. I just need to remove all of this. I don't want to build a sample. I don't want to build it into a directory, and I do want to do P, so I build a fresh one, and then I want to go always. Okay, so that's number one. So PM starts. I can't use PM starts. What? NRF54 Nordic. Yeah. So okay. So there's something that I can't do because of my SOC. Okay, cool. Thank you. Therefore, so it turns out we can't even use power management, and I have a feeling it's because of that power tuning thing. But that's not a problem for now. We shall just remove them, and we shall just rebuild, and we can see what happens. Bluetooth H. I genuinely would be surprised if it just built all the way, to be honest. And while it's building, I will pull out the NRF52 page so that I can copy the building and provisioning commands. You're playing. Oh my, what? So we built. So here we'll do where in NRF util, and then we'll do NRF 5 SDK, and then it's tools, package this thing, and generate the package, and then that, and then this is HW version, this is the 5.2, and then next we're going to ask it to SD rec is cross 00. Wait. Okay, and then after that we're going to tell it the application is in build Zephyr dot hex, and then we're going to tell it the version of the application version is 1. Let's just keep it at 1. You can always go back to that later, and then we can see LP BLE zip. Make it into that. Can we do that? It's gonna go warning. Yeah, we're back to the unsigned builds. Today we're not using MCU, but it's just, well, to be honest, if I could deploy via BLE, it might just be easier to use MCU boot, but NRF 5 SDK dash tools, and then DFU USB dash serial. I can probably use Bluetooth there. Package is LP BLE.zip dash p, and then we'll send this to the dev tty scm0, and we should have a small progress bar at the bottom quickly. I wonder if this works all the way, all the way. So, and then here we'll do screen, the same device. Oh wow, so we are in low power. We are in low power mode, and I think we can, let's see. So I know the NRF application, the Nordic application. So yeah, we showed up. I wonder if you can see that, but we did show up. Temp and light, that's us. And let's see. I think at some point we can watch some stuff. Wait, to connect. Why? Yeah, it's connected. Connectable, yes. Oh yeah, I think I can see. So look at the if you look down here, you can see at how many events we're getting, how many Bluetooth events we're getting. Okay. So the thing is, we're going. You can see we're going 1 second long before we get an event. If I don't know if I can, I don't know how visible it is. But on the screen, I'll upload some images. I'll upload some images later so that we can see. What you can't see here is that how do I say this? We are only advertising once per second. And what is happening, we used to, if I switch back to the thing that we were, if I switch back into, let's go to the BLE service. If I switch back to the BLE service that we were in, what would that happen? So here, instead of using this, we were using BLE ADV Con 1. BLE. Shit. Which one are we using? I forgot. Sorry, fast one. Con. Fast one. Just go forward. Con fast one. We were using this. BLE con fast one. BTLE ADV con fast one. So here, BTLE ADV fast one. Let me show you. I found a way of showing how we are saving power. So let's go back here and then let's do the same fasting. So yeah, that's fine. That should be okay. Let me find the YouTube window so I can see let's see if I'm showing. Okay, cool. So it's here. So what I'm trying to show you on my phone screen is that there is 1 second gaps between the man, so silly. Yeah, so there's 1 second gaps between there is 1 second gaps between the advertisements. You see? And that is quite significant because if there's 1 second between the advertisement, we can arbitrarily set those gaps to be as big as we want. So this is back to the older one, Let's package it into HP BLE. Yeah, and then instead let's flash HP BLE, high power BLE. And I'm going to, sorry, I didn't flash, I just scrolled by mistake. I'm going to put it in bootloader mode. We are in bootloader mode now, and I'm going to flash. And then if we go back to this screen, we'll find that it died. Yes, it's flashed now, so let's start the console. And what I want to show you is I'm going to connect again on the thing, and then we're going to see. Yeah. I'm just connecting, and I want to see how long. The intervals are not set, they're not being used, so it is connecting. Let me see if I can close the Nordic app and then open it again. Aha. Look, so if you can see, you'll see between the yellow dots it says there's milliseconds. Okay, so it's basically, I'm just trying to make sure it doesn't go off. It's basically advertising every 200 milliseconds. Every 200 milliseconds it's saying, I'm here, come and find me. And by changing our advertisement parameters, our advertisement connection parameters, okay, so by changing our advertisement parameters, we can adjust how long the radio on the device announces its location. And remember, this is a power. This is something that uses power. Every time your radio announces I am here, it is using power. Every time it is using power. And basically, so by going to this format, by going to this custom one that we have here, which is LP ADV params, what we are doing here now is we're starting to finally control the work that our radio is doing. When is it advertising? When is it not advertising? When is it pulling data? When is it not pulling data? And all of those things. And by adjusting those things, you can now start to arrange your application in such a way that it's not wasting a lot of time. I'm going to have to investigate. I thought config power management was just normal, but it turns out it could be not covered on the NRF 52, which is quite odd, because it uses Nordic power. So Nordic power, there is Nordic power. Can I config search? Is there Nordic power NRF power NRF PM. Why am I looking around that much? Nordic NRF Nordic Power. Yeah, can I go to that? Can I set you up? Let's look at the source code. NRF Nordic Power. Nordic NRF Power. Source. Sorry. Let's look at Nordic NRF Power. So let's look at that. Nordic NRF Power. You should at least give us some YAML somewhere. So what are you? Nordic NRF Power Control Module. Cool. So all I need to do for that is just set it up. Well, I don't even need to set it up because let's check. Let's check out DTS. Cut build zephyr.dts, and then we grep NRF power, and then let's do A5 B5. So that's disabled. Uh, 52,840, 52,840. Yeah, it's there. I mean, you can just do power, power. Nordic and RF power. Why the? Oh, okay. Anyways. Nordic and RF power, and then A10, B, let's do a B5 and A10. So yeah, status. Oh, okay, we don't see a status there. So A15 maybe. There's that guy in there, that's okay. And then I guess that's okay. This is not status. Yeah. I'm sorry. So it is the status okay is here. Nordic NRF power is enabled. And I guess we're not doing power management on this thing because power management here is handled by the Nordic NRF power tuning device. And if we recall correctly, we did we do have documentation that will show this dongle. Yes, we'll have power. Yeah. Power tuning. No, I know there's a power. Anyways, let's just go through them. Yeah. It has a. No, that's external flash. But yeah, so this is exactly what I wanted. Power management unit by Nordic. So as we recall from the other day, remove the search. The Nordic NRF that we're using has its own power management unit. So I don't think we are able to use Zephyr's power management because this actually it's almost like a standalone item by itself. It's in there, it's watching what the CPU is doing, and it's trying to make the CPU go up and down as much as possible. So it seems as though power management is already. How do we transition between power states? Can I build a power management sample, but for this device? CD Zephyr none, and then Zephyr, and then samples, and then subsys, and then PM, and then in here we have device PM, CD device PM, and then in here we want to do west. Yeah, we can just go up. This one's the same way we did right now. So let's build a sample here. Yeah. I'm assuming this uses PM, and it will maybe show me how to use. Yeah. Okay, cool. Here we go. So even the power management sample does not work on the device. So there, we have established that is the case. This is because the Nordic PM unit so leave subsys, leave PM, leave samples, leave Zephyr, go into applications. Yeah, where are you? Applications. Custom. Yeah, SG90. Oh yeah, that's fine. That was the motor. Okay, cool. So we can't run power management on this one. So let's quickly run through a recap of what we've done, so that we just observe what we've done today. So what have we done today? I have some notes here. What we've done is we've gone through our normal Bluetooth application, and we have built up different connection options. We're using different connection options so that we can adjust how long we are on and how long we're off. How basically the gaps between how long this radio goes on and this radio goes off is what we have adjusted. When the more of a gap you put between the latencies, the intervals, the more the radio will be off and the more power you will have. So basically, right now in our settings, it's advertising every second. But if let's say we have this thing in the wild, completely in the wild, and it needs to run on a battery, and this battery can only be picked up every 2 months to be charged. We can make it advertise maybe every 1 hour, or maybe even every 10 hours or something. It depends. And all of this power savings isn't just like you get power savings and you throw them at your device. What you do is you carefully consider every scenario that you're going through, and then you choose how long. And then there's if you go through this blog that I've written, or rather it's not even a blog really, it's just a bunch of notes from my studies before the stream today, you'll find that so there's a few things that we can kind of explore. You can't go between advertising modes, okay? So the thing is, you can, it's like your headphones. Whenever you want to use your headphones, what you will do is you'll press a button, and then they will become discoverable. And then when they become discoverable, you can connect to them. But once you've connected, because you're now on a whitelist, you can now just, it don't have to be discoverable. And let's look at a couple of options. Why does my Bluetooth mouse always go off during the Bluetooth stream? Damn it, mouse. It is one of the cheapest mouses. Yeah, so don't blame me for it not working. Cool. So let's look at this. What did I promise we're going to look at? switching between modes. So here, LE param update. First of all, I wanted to see connectable, ADV con BLE ADV con first one. What is this? Con first one. Yeah, connectable advertising. You can also not be connectable. You can also just advertise, and you see there's an advertise one time and advertise as connectable. You can advertise, there's none. And then you can use low duty cycle when you want to the duty cycle is how long the radio is on. Remember, if you have a wave, if you have a wave and you want to determine how much of assume you have a square wave, and in this square wave you have a duty cycle of 50%. 50% means you're on 50% of the time, you're off 50% of the time. You can adjust your radio duty cycle so that between your intervals your radio is on maybe 10% and is off 90%. And all of these are things that you adjust depending on what you need. If you need high throughput, if you need high bandwidth, if you need high connectivity, if you're swapping devices quickly and you always have power, you don't need all of this. But if you're not swapping devices quickly, all the devices you're connecting to are known, you can stay very low on the power budget. And then let's put this in here so that we can just look at it and what it does. BLE param update. Yeah, this is the con.h. So this is a function. Updates the connection parameters. So basically you can go from being discoverable to being not discoverable. That's what your headphones are probably not using low energy Bluetooth, but that is the same concept that appears. It basically advertise as discoverable and then don't advertise as discoverable. So you can switch between these modes. Basically, or remember that device that's in the field that we were talking about? It could have a button or it could have a message so that when it does connect, say it just does one every 20 minutes. And then when it does connect and it does discover that it's connected to someone it knows, it switches and it goes to the fast mode. And then in the fast mode, it transfers a lot of data quickly and then you go back, you see. So, and in the real world, you will find that you will need more than one of these advertisement parameters, or rather advertisement parameter options. And this is going to affect how you... These are kind of the tools that you're going to be able to use to implement low power connections or low power networking. So it comes down to compromises. What are you going to give? What are you going to take? It comes down to whatever settings you have for your network device, and it comes down to the specific situation that you're actually handling. Anyway, that was a good, I think, an hour of a stream. You can find these notes. Here on my blog, or rather on guyouches.com. And let's do a commit so that we see git status. What did we change? Git. Let's do git. Relax. Git diff. So Bluetooth service is good, that's fine, but the main one, we don't need those changes. We don't need those headers. So let's go remove those useless headers in our main. I could have moved straight from there, but it's fine. Let's remove the power management because we can't use this power management on this device. Okay, cool. And then other than that, let's git status again, git diff. Yeah, we don't need to add more PRJ. Yeah, we don't need to do more spaces. And then git diff Okay, so only changes are to BLE service and to power. Okay, git status. Okay, git add. Let's add the whole of the source folder. Git. What did we change in main? Just a comment. Git commit. Git add the source folder. Git commit. Not format. Git commit -m. In here we will start adjusting BLE advertisement params for power savings. Okay, this one is small enough that I'm just gonna push it to main, and it's direct enough, you know. Okay, cool. Thank you so much today, and that's how you do low power BLE networking. Join me tomorrow. I'm not so sure what we'll be working on, but we'll be working on we'll be working on something for sure, and it's gonna be fun. Thank you. Cheers. This has been amazing. Let's see. Maybe there's a couple of questions. No, I'll just jump straight out. But there is a question. Oh, wait. I've been following along with you, updating the header files for low power. Interesting idea. Very nice instruction. Oh, amazing. Yeah. Do you wait before you leave? What headers are you updating for low power? Which headers? So I'm talking to mnemonic 6502. That's a really low. That's a very embedded name for YouTube. Mnemonic. Let's wait for you. What headers are you adjusting? Does anyone have any questions on WhatsApp while we're waiting for this? Well, he might have left. But I guess some of us are following along. Some of us are pulling this code. Some people are using this code. That's really amazing to see. Thank you so much, everyone. And cheers. See you tomorrow. We'll do something amazing. Bye.